All right, hi guys. So welcome to part 2 of graphing square root and cube root functions. So in this video, we are going to cover more complex transformations happening. So not just shifting left, right, up, down, which is very easy to just do with the graph itself. We're going to be needing the key points so that we can then transform those based on the transformations that are given to us on the examples. So first, let's go ahead and I want to remind you of the square root function. Key points are 0, 0, 1, 1, 4, 2, and 9, 3. The key points for the cube root function are -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. All right. And if you ever forget, again, they're really just, for the square root function, the first 4 that are perfect squares, that will give you a whole number result. And the same thing for the cube root, except with the cube root, you can have negative x values, so you use both negative and positive values. All right, so we're going to work on number 3. It says describe the transformation, determine the domain and range, and then sketch the graph. All right, so let's go ahead and describe first. So what are the transformations that are happening? Well, I see, remember, you always want to start with what is happening to the x value. So what I see happening to the x value is, it looks like one thing, but it's technically 2 separate things, right? We're multiplying -8, but really we look at the negative separately, then we look at the 8. The 8 tells us the stretch or compression. The negative tells us reflection. So the order that you write this down doesn't matter. Since multiplication is commutative, you could do the reflection first, then the stretch compression, or you could do the stretch compression first and then the reflection. I always do the stretch compression first, so I will write that first. Now, what is the factor? It's the reciprocal of 8, which is 1/8. So the factor is actually 1/8. So this is a horizontal compression, since the factor is 1/8, which is smaller than 1, by a factor of, and then you just say the factor, right? The factor is 1/8. And we have a reflection, and we change the sign of the x. So this is a reflection over the y-axis. All right, so those are the transformations, okay? So to the x value, and I sometimes like to make a little note, right? So to the x value, we are going to multiply 1/8 and then multiply -1, because we have to change the sign of the x value as well. So we have to do both of those. Multiply 1/8 and then multiply -1. We could technically do 2 for 1 special. We can multiply -1/8 at the same time. So notice that I didn't write any more transformations because nothing else is happening to the function. Nothing is happening on the inside with x anymore other than just multiplying -8, and nothing is happening to the y value. Okay, so next up, what I will do is I will write my transformations. Now, the y value is going to stay the same. The x value, I'm going to multiply by -1/8. Okay, so the x value, I will literally take the x value and multiply it by -1/8. So the y value is going to stay the same. So all of these, again, look at the kind of function that you have. Okay, so be careful with that. Look at the kind of function you have. You're looking at the cube root here. So I'm looking at the cube root parent function. All the y values are staying the same. -2, -1, 0, 1, and 2. Now the x values are all going to change. I'm going to multiply by -1/8. Now, -8 times -1/8 is just 1. -1 times -1/8 is 1/8. 0 times -1/8 is 0. 1 times -1/8 is -1/8. And 8 times -1/8 is -1. Now, -1/8, I will just go ahead and write that as a decimal, which is about 0.1, just because I'm using this for graphing purposes. So I will write this as the decimal because it makes it easier to graph. So positive 0.1 and then negative 0.1. All right. So now we have our ordered pairs and we can graph it and we're done. Okay, so 1 and -2, 0.1, so very, very close to 0, and -1, 0, 0, -0.1, so very close to 0, but on the negative side, and 1. And lastly, -1 and 2. Okay, and then we are going to go ahead and connect the dots, and there you go. Now, if I wanted to be a little bit more good, like this sketch is very, very small because it has like very small amount of x values. What I would suggest in this case is to add a couple more x values. So I'll add just some x values that are further away, so that way I have you know, a good range in my, I guess I shouldn't say range because it's for the domain, but I have a good number of points on the outsides for my graph for the x values. So I'm also going to plug in into this function, I'm going to plug in the x value of 8 and the x value of -8. Actually, I don't really need to put it up there. I could just put them down here. So I'm just going to plug in 8 and -8. And for this, I'm not going to use like transformations, right? Because I don't have where those points are going to be from. I'm just going to use the function itself. In theory, you could also do that for the function itself for graphing. You could just plug in x values as long as you knew where the center was, because you always want to graph the center. Same thing for the square root function. You always want to graph the extrema. So anyway, so let's plug in -8 into our function. So I'm taking the cube root of -8 times x, and the first x value that I'm going to plug in is -8. We get 4. And I'm going to do the same thing, but the x being +8. So I have the cube root of -8 times x, and x here, we're plugging in +8. That's -4. All right, so now we can go ahead and graph these. So -8 and 4, and 8 and -4. And then we can go ahead and extend this graph, and that just makes it so that we have a more accurate graph, right? So I'm just gonna boom, connect the dots, there we go. And I like to do this just so that I have a more accurate graph, but technically it's not really necessary for a sketch. All right, let's go ahead and move on to part B. So in part B, first, again, you want to look at what kind of function you have. So in this case, look at the radical. It's a square root. So this is a square root function. So we are looking at, these are our parent function's key points. And first, let's go ahead and just describe the transformation. So let's go ahead and write what's happening to x and what's happening with y, and then we can go ahead and write out the description. So start with x first. It looks like +5. Remember, everything with x is the opposite. So we're actually going to subtract 5. And then a lot of things are happening to y. We have multiplying -2 and subtracting 4. So we can, when we do the operation, we can do the multiplying of -2 obviously all together, because multiplying a negative and then multiplying 2 is the same thing as multiplying 2 and then multiplying a negative. I usually, when it's with y, I will do the negative first and then multiply the number. But it really doesn't matter. You could do it the other way and then it'll be true anyway. You can do it all together also. I just like to write them separately, so when I write the description, I could see that those are two different transformations. One is the reflection, and then the other one is the stretch. So the last thing is a -4, so I will subtract 4 to the y value. Okay, so let's go ahead and write out the description, right? We have again, we start with x, so a horizontal shift left 5. Then multiplying -1, we're changing the sign of y, so that'll be a reflection over. We change the sign of y, so it's over the x-axis. Then we're multiplying 2, so That'll be, because it's to y, vertical. It's bigger than 1, so stretch. And then you just say the factor. By a factor of 2. Lastly, we're subtracting to y, so it'll be a vertical. Shift. Subtracting, so down. And the number is 4 units. So that is the description of the transformations that are happening. Now let's go ahead and write our table. Now, what's happening to x is we are going to minus 5. What's happening to y? Well, to the y value, we're going to go ahead and multiply -2, and we're going to then subtract 4 in that order. Now, our original x values are here. To each one, we subtract 5. 0 minus 5 is -5. 1 minus 5 is -4. 4 minus 5 is -1. 9 minus 5 is +4. Now move on to what's happening to y. Each of these y values, we'll go ahead and multiply -2 and then subtract 4. 0 times -2 is 0. Minus 4 is -4. 1 times -2 is -2. Minus 4 is -6. 2 times -2 is -4. Minus 4 is -8. And then last, 3 times -2 is -6. -6 minus 4 is -10. All right. Let's go ahead and graph those now. -5, 2, 3, 4, 5, and -4. -4 and -6. -1, -8. And 4, -10. Again, remember, keeping the extrema in mind is important. Here was the original extrema. This were the points when I transformed it. So this is still my extrema. So this is the end point, and then my arrow will go in the other direction. All right. So there we have it. Now, we do need to write the domain and range for both of these. I almost always forget how to, not how, but to do that. So don't forget to answer all parts of the question. So domain and range. Luckily on part A is very easy. This is the cube root function. So it's just all real numbers, -infinity to +infinity. Now for the square root function, multiple things happen. We flipped it over the x-axis. So not only does that affect, does the domain and range get affected by shifting left, right, up, down, but also reflecting changes the domain and range as well. So let's think about it. We took our graph, right, and we shifted it to the left 5 units, right? So after it gets reflected over the x-axis, that doesn't affect it any further. So the domain will start at -5 and then go to +infinity. Okay. Now that would change if the reflection was actually over the y-axis. In this case, it was a reflection over the x-axis, so it only affects our range, not our domain. The reflection does. Now, what about the range? Now, we reflected it over that x-axis, so now instead of pointing up, we're pointing down, which means that the lowest is the arrow. We're going to smallest value, -infinity, and then the highest value will be -4 because we had to shift down. We had to shift the extrema down 4 units. So the range will be from -infinity to -4. Now, the easiest thing whenever you're finding the domain and range is probably just to make a quick sketch of the graph. The only things that affect the domain and range are your shifts, up, right, left, down, and then your reflections. So you don't really need to be that specific with the stretches. So if you just figure out where is the new extrema and then which way am I pointing? Am I still pointing up and to the right, or am I now pointing up but to the left, or am I now pointing down and to the right, or am I pointing down and to the left? So you just have to look at how is the reflections and then where is the new extrema, and then finding the domain and range is very easy. Okay, Let's do one more example, and then you can try a couple on your own. All right, so let's take a look at A. Okay, and again, I first look at what is my function as the cube root. So the parent function that I'm going to need is for my cube root. Okay, so that'll be -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So that's the parent function key points. Now, what's happening to the x value and what's happening to the y value? Now, everything with x is opposite, including order of operations. That is the piece that is the most difficult for students to remember and the place where you get the most mistakes, because you always forget that. Everything with x is opposite, including order of operations. Everything means everything. So normally what would we do? We would work inside parentheses. So don't do that first. The other thing, multiplying 2. But we're not actually multiplying 2. We're multiplying the reciprocal. So we're going to multiply 1/2 first. Then inside parentheses, we're going to -1. But are we actually minusing 1? No, we are adding 1. Okay, now on the outside, what's happening? Well, we do have a multiplying of a negative here. So we are going to multiply y by -1, which will just be the reflection. So let's go ahead and write our description, right? For starting with x, we are going to horizontally multiply by 1/2, which the factor there is less than 1. So it's a compression. So horizontal compression by a factor of 1/2. Then we are going to add 1, so that will be a horizontal shift, right, 1 unit. And then multiplying y by -1, so that'll be a reflection. If you're multiplying the y, you reflect over x. All right. I guess I could write x-axis to be very precise. So that is the description of what is happening to the transformations. Now, moving on from there, we can go ahead and apply those operations to the functions, okay? So to the x value, I will multiply by 1/2 and then add 1. To the y value, I'm going to multiply by a negative. That's it. So let's do the y value first. This is easier. Multiplying each of those by a negative. 2, 1, 0, -1, -2. Now, the x value, multiply by 1/2 and then add 1. -8 times 1/2 is -4. -4 plus 1 is -3. -1 times 1/2 is -0.5. -0.5 plus 1 is +0.5. 0 times 1/2 is 0. 0 plus 1 is 1. 1 times 1/2 is 0.5. 0.5 plus 1 is 1.5. 8 times 1/2 is 4. 4 plus 1 is 5. Okay, now we have the points of our new function. Let's go ahead and graph them. -3 and 2. 0.5 and 1. 1 and 0. 1.5. Oops, I think I did mess up. Let me take it back a step. When I graphed 0.5, I graphed -0.5 when I should have graphed +0.5. So let's do that one again. So that's the 1, 0. 0.5 and 1 is actually here. And then 1.5 and -1. And then lastly, 5 and -2. Okay, so now we can go ahead and connect our dots. And there we have it. Now, domain and range. I'm not forgetting this time. This is a cube root function. Domain and range is all real numbers for both, -infinity to +infinity. Okay, part B. Looking at this function, this is the square root function. So we will use the key points for the square root function, y equals the square root of x. So those key points are 0, 0, 1, 1, 4, 2, 9, 3. Okay, now what's happening, right? Describe what's happening to x, what's happening to y. Now, everything with x is opposite, including order of operations, like I just said. So normally what would we do? We'll multiply first, right? Multiply -1 first, then add 3. So we are actually going to do the opposite. We're going to do this first. But instead of adding 3, we would do the opposite, -3. And then we will multiply -1. Now the reciprocal of -1 is just -1, right? Multiplying -1 and dividing -1 is the same thing. So that one's the one that we kind of get away with. Even if we mess up and forget that it is supposed to be the reciprocal, you would still get it right because the reciprocal of -1 is still -1. Okay, and then what's happening on the outside? Well, nothing's multiplying, but we are adding 5. Everything with y is exactly as you see it. So add 5, boom, just like that. Okay, let's write the description. Again, start with x. So -3 first, which means that we will horizontally shift left 3, then multiply by -1. So we're changing the sign of the x value, which means we will reflect, if we change the sign of x, we reflect over the y-axis. Okay, and then we will add 5 to the y value, so that is vertical shift up 5. And those are the transformations, the description of the transformations. Now let's go ahead and actually transform these points, okay? Actually, let me leave a little bit of space so that I can write my rules. I like to do that just so that I, am organized. Organization is key here. So to the x value, I will subtract 3 first. Then I will multiply by -1, okay? To the y value, I will add 5. So each x value, subtract 3 first, then multiply by -1. So 0 minus 3, -3, times -1 will be +3. 1 minus 3 is -2. -2 times -1 is +2. 4 minus 3 is 1. 1 times -1 is -1. And 9 minus 3 is 6. 6 times -1 is -6. To the y value, I'm just adding 5. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. And 3 plus 5 is 8. Okay, let's graph it. 3, 5. And again, this is my previous extrema. So guess what? This is my new extrema. If you want, I like to get into the habit of graphing it just like a little bit darker. So remember, that's my extrema point. 2, 6. -1, 7. And -6, 8. Okay, then we just go ahead and connect the dots. Again, extrema is the end point, and then you just go in the direction of the points and then the arrow on the opposite side. Okay, so let's go ahead and write our domain and range. And again, if you do the sketch, it's honestly the best, for finding the domain and range. So as you can see, the domain is actually going to start from the arrow because it was reflected over the y-axis. Now we shifted, instead of the arrow pointing to the right, that arrow is now pointing to the left. So you're starting with an arrow on the left, which means that the domain will go from -infinity till the x value, which is the x value of the extrema, which is 3. And then the y value, because you did not shift over the x-axis, that y value is still from the lowest, which is the extrema y value, 5. And then all the way up, because you're still going up, you're just going up and to the left instead of going up and to the right. But going up and to the left or right, that affects, left or right affects the domain, does not affect the range. So the range is from 5 to infinity. All right. So go ahead and pause this video now and try number 5 on your own. All right. So let's take a look at part A. Okay. What's happening to x? What's happening to y? Side note, this is the square root function. What's happening to x? It says plus 6. We're really going to minus 6. What's happening to the y value? Multiplying 2/3. Y is exactly as I see it. We're going to multiply 2/3. And we are going to minus 1 after. So let's describe. Horizontal, shift, left, 6. You do x first, then with the y value, we're going to horizontally. Now, is 2/3 bigger than 1 or less than 1? It's less than 1. So it's horizontal compression. Ooh, not horizontal. It's happening to y. Sorry. Let's backtrack a second. Happening to y, vertical compression. I was getting a little ahead of myself there, going pretty quickly. That's where you make mistakes, right? By a factor of 2/3, okay? Then we are subtracting 1, so that will be a vertical, subtracting 1 to y, so vertical shift, and with subtraction, so down 1 unit. Okie dokie. That is the description. Now let's go ahead and talk about our points, okay? Now, to the x value, we will just minus 6. To the y value, we'll multiply 2/3 and subtract 1. Again, I think it's like nice to just have your parent function, right? The square root of x, y equals square root of x. Just write out the points because it just makes it easier to look and reference them. 0, 0, 1, 1, 4, 2, 9, 3. So to the x value, we are going to subtract 6. I just do one at a time. Do all of your x's and then all of your y's, or do all of your y's and then all of your x's. I think it's just easier to remember what you're supposed to do to each one, right? So subtracting 6 from each one, 0 minus 6 is -6, 1 minus 6 is -5, 4 minus 6 is -2, and 9 minus 6 is 3. Okay. What's happening to y? Multiply 2/3, then minus 1. So 0 times 2/3 will be 0. 0 minus 1 is -1. 1 times 2/3 is 2/3. Minus 1 will be -1/3, which is -0.3-ish. And I'm writing it as a decimal because we're going to be using it to graph. And then next, 2 times 2/3 is 4/3. Minus 1 will be 1/3 positive. So that's 0.3. And then lastly, 3 times 2/3 is 2. 2 minus 1 is 1. Okay, let's go ahead and graph it. -6 and -1. And that is my extrema. So darker. Remember, this is my original extrema. I transformed those points, got this points. So that is still my new extrema. Still the extrema. And then -5 and -0.3, so kind of 1/3 of the way to -1. -2 and +0.3, and 3 and 1. All right, so we go ahead and connect the dots. Now notice there was no reflection here, so we are still going up and to the right. I'm going to try one last time to connect that one last dot. Barely missed it. It's okay. We'll pretend I went through it. All right. So let's go ahead and write our domain and range. Now, because this is still up and to the right, the x value is just going to start at the x value of the extrema, which is -6, and then go to +infinity, just like before. And then for the range, we'll just start with the y value of the extrema, -1, and then go to +infinity, just like before. All right, part B. Looking at part B, I do see that this is a cube root function, so I'll just keep that in mind. Now let's go ahead and just write out and organize what's happening to x, what's happening to y. Now, x is opposite or operation and order, right? So normally what would you do? Would you multiply or would you add first? You would multiply first. So we will actually do this first. Now we won't actually add, we'll do the opposite operation as well. We're going to subtract 32 first. Then we will multiply by not 8, the reciprocal 1/8. Now, moving on to what's happening to y, right? Everything is y is exactly as you see it. I see two things happening, multiplying -1 and adding 4. You would multiply first, so I'm going to multiply -1 first, and then I will add 4. So let's go ahead and write that description. So we will horizontal, always write what's happening to x first, horizontal shift, left, 32 units. Then a horizontal, the factor is 1/8. So this is a compression by a factor of 1/8. Then now let's move on to what's happening to y. Change the sign of y, which means a reflection over, change the sign of y, x-axis. And lastly, a vertical shift, so we're adding, and because we're adding up, we're adding to y. Oh, I wrote up, but I didn't write how many units. Up 4. Okay, now, again, having the key points is helpful. So y equals the cube root of x, right? The key points here for our parent function are -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Okay, so let's go ahead and write our new points, right? What are our new x and y values? So our new x values will subtract 32, multiply 1/8. Now I'm going to be a little lazy and I'm just going to use my calculator for this. So starting with the first x value, -8, minus 32. Oops, that's a negative. Minus 32. And then multiply by 1/8. Now you can do multiplying 1/8, or multiplying 1/8 is the same thing as dividing 8. So we get -5. Next up, we have -1. And again, minus 32 first. Then multiply by 1/8. And we get -4.1. 0 minus 32 is -32. And then multiply by 1/8 is -4. I knew that. I don't know why I thought about that. 1 minus 32, excuse me, is -31. Nope, not -30, -31. And then multiply by 1/8, which is the same thing as dividing 8, -3.9. And then last but not least, 8 minus 32, and then multiply by 1/8 is -3. All right, y value should be easier. Multiply by -1 and then add 4. So -2 times -1 will be +2 plus 4 is 6. -1 times -1 is +1. 1 plus 4 is 5. 0 times -1 is 0. 0 plus 4 is 4. 1 times -1 is -1 plus 4 is 3. And then 2 times -1 is -2. -2 plus 4 is 2. Okay, so let's go ahead and graph these. -5 and 6. -4.1 and 5. So very, very close to -4. -4 and 4. -3.9 and 3. And -3 and 2. Okay, this is very, very close together. So like I showed you on the other one, it might be good to plug in maybe -7, see what y value you get output for another point here, and then maybe plug in like 0 and see what output you get over here, maybe -2 or maybe something even further away. But I'm just going to take the lazy route and just connect these dots instead of making a more precise graph. Good enough. All right, so hopefully that was helpful. Remember, use your key points, everything with x's opposite, including the order of operations, and just follow through. You know what? I almost forgot, looking at this example now, I almost forgot to do the domain and range, but it will be easy because remember, cube root function, no matter how you transform it, you will always have arrows on both ends. So this will be -infinity to +infinity. All right, guys, I'll see you guys in the next video. Bye.